So this question's got parallel lines on, it's got shapes, and within shapes it's got triangles, and it's kind of shouting out that it might be something to do with similar shapes. So therefore we'll have a look at the information and see what they actually want. And they're giving us all this information repeated, and then they're telling us that we've got to find the value of x and y. It's got no right angles in it, it's got no angles given to us, so it's not going to be sine rule, cosine rule or trigonometry, all those kind of things. No right angles for definite, therefore it's not Pythagoras. So we're kind of going through our skill set and suggesting what things will work for shapes where we've got to find different lengths. And similar shapes shouts out at you, and therefore similar shapes, one of the ways that tends to work quite nice is to find scale factors. So because we recognise this is about similar shapes, and we know they're similar shapes because of the parallel lines, and corresponding angles are going to be equal, because here, for example, look at these two little this shape here, we've got two triangles. So we've got a small triangle EAD, and then we've got a large triangle ACB, and we can see that the angle at A has to be the same for both, so those two angles are the same. And we can see, because of the parallel line theories, that this angle here has to be the same as this angle here. Corresponding angles are equal, and by the same theory these two angles have to be equal, so corresponding angles are equal. And because we've got two shapes where all the corresponding angles are identical, and they've all come from a common point, they're an enlargement of each other, then they are similar shapes, and therefore scale factor will work. So the first thing to do is work out the information we've got. So we know that's 4, we know that total is 6 from A to B, we can see that it's 4 plus 2. We know that's x plus 5, because we're going from A to C, so it's those two added together. So that's going to be x plus 5, and A to E is 5. So we can see from here then that we've got two corresponding sides, therefore we can get a scale factor. And the scale factor is equal to the new length of 6 divided by the old length of 4, and we can see the scale factor is 3 over 2, which some of you will prefer to see as 1.5. So we know then that to go from this triangle to this triangle, we multiply by the scale factor of 1.5. Therefore, to go from this side to this side, we also multiply by 1.5. So in our answer box, then we can be thinking that 5 times 1.5 equals x plus 5. That's basically what the information is telling us, that if I multiply 5 by 1.5, it'll give me the whole of this length. So 5 times 1.5 we recognise is 7.5. Well, this tells you straight away that x must be 2.5, because I take away 5 from both sides. So x is equal to 2.5. So that's the first part done, because the first part said find the value of x, so that's what's been done. We've then got to find the value of y. Well, again, we can see here that we've got a triangle, so we can sketch that out, and x, a, and y, big y across, and then this is the little y. And they're telling us the length of AX is 9. We need a corresponding triangle to this one. Well, let's have a look. That angle is the same as that angle. By parallel lines, we can see that this angle here is the same as this angle. Oh, we'll go for the big triangle because we know everything about that. So this angle there. So x is the same as b. So in our triangle here, x is the same as b. A is common, so A is the common angle, and therefore from the big triangle ABC, then this must be C. So put on lengths we know. Do we know the length of AC? Well, yeah, we worked it out a minute ago. We know that's 5 and 2.5, so we know that's 7.5. Do we know the length of BC? Yeah, we know it's 4. Do we know the length of AB? A to B? Yeah, we know it's 6. And do we know the length of anything else? No, but we've got all the information we need because we've got corresponding sides. So we know that we've got corresponding sides here of 6 and 9. So again, we work out the scale factor. So the scale factor between these two triangles has got to be 9 divided by 6, which is 1.5 again. 9 divided by 6 cancels down to 3 over 2, 1.5. So therefore 7.5 times 1.5, because if we're going from the little triangle to the big triangle, then multiply by 1.5, and the corresponding side here to get y is 7.5 becomes y. So we times by 1.5 again. So to get y, then we've got to do 7.5 times 1.5. Well, when you multiply by 1.5, it's like saying 7.5 is one of them plus a half of 7.5. So 7.5 plus, well, half of 7.5 is 3.75. Excuse me. And then when we add those together, we get 11.25 centimetres, of course, because this question is about centimetres. So for y, we found out that it's 11.25 centimetres, and for x we found out it's 2.5 centimetres. So again, this question came down to recognising that we needed lengths, knowing other lengths, and the shape can be broken up into different triangles. Therefore it's kind of shouting out at you to do similar shapes approach, and for similar shapes, scale factors is usually a good way to go for, because then we can see how one shape becomes the other by finding a scale factor, and then the same scale factor then must happen for how to turn the little triangle lengths into the big triangle lengths and so forth. So that's how that question could be done. Those were the answers.